students. Now we are going to solve the problem number 2 in single step, right? So now a 300 ohm transmission line is connected to a load impedance of 450 minus j 600 ohms at the frequency 10 Hz. We need to find out the distance and length of the short circuit steps required for matching, right? So what is the first step in switch chart? Right. So first step is to find normalized load impedance. Small zr equal to what? Capital Zr divided by capital Zr. Right. So what is capital Zr? 450 minus j 600. What is capital Z naught? That is 300. So now what is the value? 450 divided by 300 minus j 600 divided by 300. So what is 450 divided by 300? Yes, that value is what? 1.5 minus j2, right? So what is the remaining steps? That one I have explained you already, right? So these were the remaining steps, right? Next step is to plot a small zr in switch chart. You have to draw the VSWR circle, uh, and then 1 comma 0 is the center, and small zr is the radius. Draw the 1 plus JB circle, and you have to find out YR by extending the value of zr either upward or downward. Then you are going to find out the distance, right? The same thing I am going to do it, right? Fine. So what is the first step? Small zr 1.5. So what is the value of small zr here? 1.5 minus j2, right? So what is 1.5? Where the value is 1.5. This is 1.5, right? So 1.5 minus j2. So since the value is minus, you have to look at the down towards the real axis, right? So minus 2 means this one, right? So here the value is what? Minus 2. So this is minus 2. So the value is going to be minus 2. So minus 2 is going to be this, and 1.5 is going to be this one. So 1.5 minus j2. So the value is going to be somewhere around here, right? This is what? Small z, right? So this is what 1.5 minus j2 value, right? So now what do you do? Next step. See, I'm drawing in a rough manner, so please draw it wisely in your notebook, right? So this is, after this what you'll do, you'll be drawing a circle known as what? What is the name of the circle? This circle name is VSWR circle, right? After drawing VSWR circle, what you'll do, you try to extend zr from the center, right? So you need to extend opposite and also why? For which purpose we need to find extend the zr opposite side? Yes, obviously to find the value of what? YR, right? So here the value of YR is this one. So the value of YR is here. So there is value of YR, right? So now after this, what you'll do? You have to draw a circle, right? So which circle you have to draw it? Which circle you have to do? You have to draw 1 plus JB circle, right? So you have to draw a 1 plus JB circle. So now this is our 1 plus JB circle. You know how to draw it, right? So you extend that one point both at the, center, right? So either upward as well as the downward direction. So this is nothing but the 1 plus JB circle, right? So this is our 1 plus JB circle. Now both the circles are intersecting at 2 points. One is at y1, another one is at y2, right? So the upper point is always y1, the lower point is y2. Next, for finding distance, what we'll do? You have to extend that y1 from the center outer side of the switch chart, right? And similarly, from the center towards y2, draw a straight line like this for finding the distance, right? So this is what the two things you have to do it, right? So for finding the distance, right? So for finding the distance d1, what you'll do usually? For finding the distance d1, d1 equal to, right, the distance between what? YR and Y1 in clockwise and anti-clockwise. YR and Y1 in WTG, that is wavelength towards generator scale, right? And what about D2? d2 is equal to distance between yr and y2 in WTG scale, right? So now please look at here. Now let me do what, right? So here the value of yr is this, right? So this is the value of yr and this is the value of y1, right? So now we have to note it down, right? So we have to note it down, right? Between yr to y1, right? So this is our yr, right? So between yr and y1, this value is nothing but what? This is d1, right? What about d2? From this place to where? So you have to go like this and up to where? Don't go to zr, right? So you have to go up to here, right? So we have to go. So this is d2, right? So if you want to find the value of d1, d2, what will do actually? You will be looking the values of DG scale in the wavelength, right? So here you can see that the value is 0.062. Here the value is 0.172, right? So what is the distance between 0.064 lambda? Here the value is 0.174 lambda, right? So what is the distance between these two? Yes, 0.11 lambda, right? So d1 is 0.11 lambda. Remember guys, whatever I am marking, this is not the final answer, just I am explaining the procedure, because you guys are making confusion in proceeding the things, right? So that's it, right? So d1 equal to this one. And what about d2? d2, here the d1 yr location is 0.064 lambda. What about d2? 0.064 lambda. d2 location is 0.322 lambda, right? So what will do? 0.34 as of 0.324 lambda. So what is the value? So 26. So what is the value? 0.26 lambda will be your d2. I hope you know the meaning of it, right? So this is how we have to find out the value of d1 and d2. You need to mark from where you are marking d1, d2, everything, right? So next, what you'll do? You'll be finding the length. If you want to find out the length, you have to look at whether the problem is open or short circuited. Here the problem is, if it is open, then you have to start from there. All start means you have to start from here, right? One more thing, see, always you need to move clockwise direction. Don't go anti-clockwise direction. From, see, people will think, see, yr from yr, y2 is very near, sir. So can I mark the yr to y2 in a backward manner? See, is it not the correct way? Always you need to move towards generator. Don't move towards load. Okay, so that is what the procedure. Always you have to move clockwise direction, right? So next, so what you'll do for finding length, what will do? While you are tracing y2, that will be your S L1, and while you are tracing y1, that will be your L2, right? So for finding L1 and L2, what will do? Yes, yeah, what will do for finding L1 and L2? From here, from here to here, what is the length? That is L1. From here to here, right? From here to here, what is that? That is nothing but L2, right? So you have to mark it out. This is L2 and this is L1. So now whatever the value of the L1 is there in the WTG scale, that you need to subtract it by 0.25 lambda. So what is the value? 0.35 lambda minus 0.25. So the value is zero point 0.1 lambda. Similarly here 0.25, again 0.25, right? Here already the value is 0.146 lambda. So 0.146 lambda, you need to add it by which value? 0.5, because we complete one revolution. So 0.646 lambda. This value only subtracted by which value? 0.25 lambda, right? So then only you'll be getting 0. What? 396 lambda, right? So otherwise you'll be getting length as negative. Is there any possibility to get length as negative? No, right? So this is one such way to find out the length. Another way is that you can manually count. The distance between any 2 point is what? The distance between any 2 point is 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08. like that. From here to here 0.25, so 26, 27, 28, 29, like that also you can count, right? So either you can follow any one procedure, right? So this is what the thing, right? And after doing this you have to draw the, after doing these things you have to draw the diagram, right? So design diagram is also necessary, right? Right, so design diagram is also necessary, right? So let me draw it. Okay, so here this is nothing but my source. Okay, so this is nothing but our transmission line. Okay, so this is our transmission line, so you can put the corresponding value of z naught. So now this is our load, right? This is our load, this is our load z r. From the load with some distance, right? From the load with some distance only we are from the load with some distance d only we are playing, right? I mean we are placing our stubs, right? Whether d1 distance or d2 distance we are going to place the stub, right? So either you can place with the distance d1 or d2, right? Since it is a shunt stub you have to insert in the parallel manner, right? Since it is short circuited so you have to use the symbol like this, right? So and this is nothing but the, this one, right? So this is nothing but the L1 or L2, that's it, right? Now here the frequency specification is given, right? So we have to use lambda. Lambda equal to what? C by F. So what is lambda? 3 into 10 power 8. What is frequency? I think frequency is 10 into 10 power 6. So what is the value? Lambda equal to 30 meter, right? So 1 lambda equal to 30 meter means what you'll do? Already we found out the value of D1, D2, right? So you can see that. What is the value of D1? D1 is 0.4, D2 is 0. See, D2 is 0.26 lambda, D1 is 0.11 lambda, right? So D1 is 0.11 lambda and D2 is 0.26 lambda. Similarly, L1 is L1 is what? From here to here, zero point 0.1 lambda, L2 is 0.396 lambda, zero point 0.1 lambda and 0.396 lambda, right? In place of lambda you can try to substitute the value of 30 meter, right? Then the length will be represented in meters. Instead of representing the length in terms of lambda you can able to represent in meter, right? So this is how you have to draw the design diagram, right? So I hope this problem is clear for you guys, right? So we'll see in the another video. Thank you so much.